Hello and welcome to another Common Core Geometry lesson by eMATHinstruction. My name is Kirk Weiler and today we're going to be starting a new unit, specifically unit number 4, which is all about constructions. All right, and we'll talk about these in sort of the next slide and where they come from and the rules of constructions and things like that. But just as a little bit of a preview, in this unit, every single lesson you're going to need a protractor, you're going to need a straight edge, all right, and something to draw with. Okay, so let's jump right into constructions. Now, constructions are as old as geometry itself. All right, so when Euclid, who we've talked about before, was writing his book, The Elements, 2,300 years ago, he was doing constructions right along with geometric proof. All right. And in fact, there's this like famous picture that, wasn't from 2,300 years ago, obviously, but it literally shows, kind of a depiction of Euclid doing constructions with some of his students, okay? Now, there are rules for constructions, all right? And those rules are really quite important, okay? One of the rules is that a straight edge may be used only to draw segments or lines between 2 points. All right, now that straight edge will almost always be a ruler, but you will never use it to measure things. You will only use it as a straight edge to draw a straight line segment, and that's it. Okay? Second, a compass can be used to draw an arc or a circle of a known center and a known radius. And you have to have that, right? You've got to have that compass, okay? And finally, no other tools except a drawing instrument may be used. That's it. So you've got your compass, which draws circles or arcs of a circle. You've got a straight edge, which you can use to draw line segments, and that's the whole deal, okay? One other thing that I really should have put up as one of the rules is leave all of your marks, okay? Constructions have been used for a long time. In fact, before things like AutoCAD and other computer-aided drawing programs came along, almost all architects and engineers would draw plans by using classic construction techniques. Now, those folks would erase their construction marks, but you shouldn't, and we'll talk about those kind of as we move on. Now, we did some constructions back in Unit 1, and some of them that we do today are going to be very reminiscent, if not identical, to the ones in Unit 1. But I kind of wanted to start fresh, as if you had never seen any constructions before. So let's jump right in. Make sure you've got that ruler or straight edge, that protractor, that compass. I always get those two words mixed up. That compass, that ruler, and that pencil handy. Let's do it. Okay, so let's take a look at our first construction. Given segment AB shown below, do the following. All right, so we're just going to do step-by-step, follow the direction kind of stuff on here. Draw a circle whose center is at A and whose radius is equal to the length of AB. All right, well, I've got my handy-dandy electronic compass here. Now, on all compasses, there are two ends, right? There's the pointy end and there's the pencil end. The pointy end will always go at the center of the circle, and the width of the compass always represents the radius of the circle. And remember, then all points on the circle will be the same distance from the center as all other points. So specifically, what I want to do is I want to put the center of the circle at point A as much as I can. I want to make the radius of the circle equal to the length of AB, and then I will draw my circle. Okay, so simple enough. Okay, not perfect, but simple enough. Do the same, but with the center at B and the same radius. Now that can be tricky because you might want to fold up your compass really fast, right? As much as you can, when you're using the same radius more than once, you want to keep the compass at that setting. So I'm going to leave it just like that. I'm going to switch it around so my pointy end is right here. And then I will draw, whoops, and of course I lost it. That was unfortunate. But I'll draw my circle around like that, collapse my compass some, and put it off to the side. Okay, now keep in mind again, all the points on this circle lie a distance of AB away from A, and all the points on this circle wherever that circle is, lie a distance of AB away from B. Okay? Letter C says, mark one of the intersection points of the two circles. One of the intersection points of the two circles, label this as point C. So I'll label that one. Okay? Draw segments AC and BC. Okay, well, let's take our straight edge out. That's simple enough. I will connect it to point A, rotate it up, and then do my best to draw that line segment in. Likewise, now I'll put it over at B. Again, draw the segment in and get rid of my ruler. Okay, finally, explain why ABC, triangle ABC, must be equilateral. All right? Now again, we've actually done this construction, but it was way back in Unit 1. So let's think about that explanation. Take a moment and write down what you can. All right, let's do it. Maybe I'll just write the explanation up here. Okay. Because point C lies on both circles, it is a distance of AB away from both A and B. So all three sides have the same, sorry about that, length, right? All three sides have the same length. Now, a couple comments about this particular construction, or about constructions in general. You know, you probably noticed, right, this one circle, the first one I drew, slipped a little bit, didn't quite go through B, right? Possibly when I drew the line segments, I actually did a decent job on this one, but maybe they'd miss C by a little bit. Your constructions don't have to be perfect, right? You might be dealing with a compass whose pencil is dull, whose tip isn't, you know, like very well put in, right? Constructions can be quite challenging mechanically. We're not looking for perfection, we're looking for understanding. And keep that in mind all the time when you're doing constructions. It's another reason why you should never erase your construction marks, because it's in the construction marks themselves that teachers or whoever is looking at your standardized exam or test, it's through those marks that they will know whether or not you understand how to do the construction. All right? But constructing an equilateral triangle, which is the first one that we're doing, and it's this one, is actually quite easy. And again, you did that back in Unit 1. Let's go on and do some other constructions. All right. Before we do that, let's really understand the purpose of the two tools that we use. The straight edge is very simple. It has one purpose, which is to draw a straight line segment, or to connect 2 points with a straight line segment. On the other hand, the compass's purpose is a little bit strange. You would think, well, the compass's purpose is to draw a circle or an arc of a circle, and that is completely true. But in a more broad perspective, the purpose of a compass is almost always to copy a segment length or distance between 2 points. In other words, in that last exercise, right, going back to this, right, I set the radius of the compass to be the length of AB, and then I used that to copy that length all around this circle, and then to copy that length all the way around this circle. And that allowed me to identify point C up here, which was a length of AB away from point A and point B. So the purpose of a compass is almost always to copy a segment length or distance between 2 points. And we can really kind of get at this idea in exercise number 2. All right, where is that thing? There it is. Exercise number 2. Given the diagram of the circle shown, whose center is at R, with points S and T on the circle, explain why RST has to be isosceles. All right, so why does RST have to be isosceles? See if you can give an explanation for this. Pause the video now. All right, well, let's talk about it. Hopefully, you said, since S and T lie on a circle centered at R, RS is congruent to RT, right? That's the whole point. The whole point of a circle is every single point that lies on the circle is exactly the same distance from R as every other point. So point S must be the same distance from R as point T is from R. So since triangle RST has two congruent legs or two congruent sides, it is isosceles. It is isosceles. All right, this isn't supposed to be a hard problem. We just want to hammer home the idea that 100% of the time when we're doing constructions, when we make an arc with our compass, we're doing that because all the points along that arc are going to be some fixed distance away from where the pointy end of the compass is, i.e. the center of the circle. So keep that in mind as we go further in our constructions. All right, critical rule in constructions. Leave all your construction marks. 3 exclamation points. All right, so let's take a look at this one. Exercise number 3. Construct an isosceles triangle using segment MN below as the base and legs that are congruent to segment AB. Leave all construction marks. All right, so I want to make an isosceles triangle. I'm going to use this as its base, but then I want to have the 2 equal legs to be the length of AB. Okay, just the length of AB. So, how do I do that? Well, I'm going to use my compass and set it to a length of AB. And I've got to kind of turn it a little bit perpendicular here. For you, it's probably going to be a little bit easier, but I'll just stretch this out so that it's a length of AB, right? Now, as long as I don't mess up and I rotate this thing back up, I can put the pointed end at N, and I can draw an arc. Oh, I just messed up. That was unfortunate. Let me go back really quick. Well, I guess mess-ups are nothing new. I got to reset that length. And also, probably not a bad thing because it's something that's going to happen to you. You know, the compass is going to slip, right? The radius is going to change. I have to just stay away from allowing the radius to change. Here we go. Let me try it again. All right. Now, keep in mind, right? I can draw the whole circle if I'd like, but every point now along that arc is a distance of AB away from point N. If I now flip the compass and move the pointed end to M, and I draw an arc, right? All the points along that arc are also a distance of AB away from M, which means, right, this point right here is a distance of AB away from M and a distance of AB away from N. So now I use my straight edge. I rotate it up. I draw that line segment. Take my same straight edge. For me, using the straight edge, a little bit more challenging than for you. And I do this. Now, one thing that I didn't do, and I really should have done, and there you go. This would likely get full credit on some kind of an exam. But I really should have shown that I measured the length of AB. And the way that you show that you've made a measurement is by actually making a mark on that object. So that thing that I twice measured, I'm going to go back and measure one more time. Not really going to measure it, but what I'm going to do is go out like this, and then technically I should make a mark like that. And what that does, even though it's a little bit off, is it shows that I've actually measured the length of AB with my compass. And then I used that setting to make these two arcs, which allowed me to locate this point, and now I've got this isosceles triangle where these two sides are the same length as that. All right? Pretty easy construction. Pause for a moment though and write down anything you need to. All right, let's move on. Okay, one more construction. And again, if all of these look familiar, they should. We did them back in Unit 1 in a lesson that I think I called, constructing a triangle given its sides. So let's do that last little piece. Okay? Exercise number 4. Triangle ABC, shown below. Construct triangle RST such that triangle RST is congruent to triangle ABC. Use point R as a starting point. All right, so I want to create a triangle over here, RST, that's congruent or identical to triangle ABC. Okay, so what I'm going to do is I'm going to take my compass. I'm going to put the sharp point at A. I could put it as B as well, but I'm going to put it at A. And I'm going to mark off the length of AB. Okay? Now what I'll do is I'll bring my compass over here, put the sharp point on R, and mark that length over here. Now what does that mean? What it means is I've really created a segment over here that's the same length as AB. What should I actually label this point as over here? Well, I should label it with whatever letter corresponds to B in my congruence statement, and that would be the letter S. Now the only question is, where do I put point T? And it should be somewhere up here, right? How do I locate it? Well, what I'm going to do now is I'm going to take my compass, okay, and I'm going to take my ruler and get it out of the way. I'm going to take my compass, and I'm going to set it so that it's got a length of AC. Actually, I think I'll put the pointed tip at A, not that it matters. Bring this down, and I'm going to measure off a length of AC. Now what I'll do is I'll bring my compass over, put the sharp end at R, and I'll make the same type of arc. Okay? What you'll notice a lot in constructions, let me get the ruler out of the way. What you'll notice a lot in constructions is that oftentimes you do things on one picture and then you reproduce the exact same thing over here. So I made the arc here of AC, and I make the same arc over here that has the same radius. You probably won't be surprised by what comes next. I'm now going to take the compass and put the sharp end at B, rotate it a little bit like this, and then stretch it out and mark the length of BC, like that. Just like before, I will then take this compass, bring it over to S, and make sort of the equivalent arc. Very often in constructions, X marks the spot, and it definitely does now. This now will be the location of point, well, what is it? Point C, which is point T, right? All I now have to do is use my straight edge to connect all the points. Let me do that really quick. All right, so if I bring this down here, again, this is definitely something you'll be able to beat me on. There we go. Rotate it up, and there we are. All right, there we go. They certainly do look congruent, all right? What I'm going to do is I'm going to just test it really quick. I could use some tracing paper, right? There's my original triangle. Let's see how good I did with the construction. If I bring this over here, not bad, right? Pretty much lies right on top. It's not perfect, but that goes back to my point. Constructions don't have to be perfect. You just have to show all of the marks, right? That's the whole deal. Copying a triangle, given its 3 side lengths. Now the last little piece, and Euclid always did these in his constructions, is a proof of why the construction works. Now the first proof of a construction that we're going to do is right below this problem, but it's also very, very basic, and that's okay. Let's take a look really quick. Fill in the steps below to prove that the 2 triangles are congruent based on this construction. Well, why was RS congruent to AB? Well, they were congruent by construction. What does that mean? By construction, they're congruent. What that literally means is that I forced them to be congruent. By the very nature of what a construction is, those 2 line segments are congruent because I went up and I copied the length of AB and I put it over here. That's just the deal. Why is then RT congruent to AC? Again, I hate to say it, but it's by construction. I came over here, I marked the length of AC, and then I marked it over here, right? Likewise, why is ST congruent to BC? Also by construction, right? I forced the 3 sides of the triangle here to be congruent to the 3 sides of the triangle here. So why are those 2 triangles congruent? Well, that's by the side-side-side theorem, right? And it really gets at this larger principle, which is any time that you have 2 triangles that have 3 pairs of sides that are congruent to one another, those 2 triangles have to be identical. The angles come along for the ride, which is really kind of neat. All right. Anyway, let's wrap this lesson up. Where's my advance? There it is. So in this lesson, we saw some very important things, which were the rules of constructions and what the tools of constructions do for you. Remember, really, only 2 really big rules, maybe 3, depending on how you count. 1, you can use a straight edge only to draw straight line segments. 2, you use a compass to copy distances. 3, leave your construction marks. That's basically it, all right? Understanding why constructions work, well, that actually takes geometry that we've already seen in previous units. And as we move forward with constructions, we'll continue to see the triangle congruence logic that lies behind all of them. Today, we really just created an equilateral triangle, an isosceles triangle, and then copied a triangle whose side lengths were known. And by known, I mean they were sitting there and we could take the compass and copy them. All right. We'll see more complicated constructions as we go further, but all of them will have triangle congruence reasoning behind them. For now, I'd like to thank you for joining me for another Common Core geometry lesson by eMATHinstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.